Sparse Embedding Representation, a smart model that focuses on what matters. So let's see what it is. So have you ever felt like your AI model is just too big, too slow, or picking up too much noises? You are not alone. Today we are diving into a powerful concept that making waves in the world of machine learning. Yes, you heard it right. Sparse Embedding Representation. And trust me, this one is a game changer. So what are embedding anyway? In many AI system, or I would say in many AI and ML system, especially the NLP or recommended system, we use embedding layers to convert inputs like words, users or product into numerical vectors. These vectors help the model understand relationships and patterns. Traditionally, these embeddings are dense, meaning every dimension in the vector has a value. Sounds good, right? Well, not always. So, let's see. A dense embedding can be a huge billions of parameters, especially when you are working with a large vocabularies or a passive data sets. But here's the kicker. Most of those values are either redundant or irrelevant. Enter sparse embedding, less is more. Instead of giving a very feature equal weight, sparse embedding zero in one of the most important ones. Imagine a vector where a handful of positions have actual values and the reset are just zeros. It's like clearing out the clutter and only keeping what really matters. So the perks of going sparse. Number one, smaller model size. Be only keeping relevant features. You don't need to store massive vector for every input. This dramatically reduces memory and computational load. Perfect for edge devices or cloud cost saving. Second one, more interpretability. When only a few dimensions are active, it's easier to understand what the model is focusing on, and this can be crucial for debugging or explaining model behavior. Point number 3, better performance. Fewer distractions mean more accurate prediction. Sparse models tend to generalize better, especially when trained on large and diverse datasets. How do you make embedding sparse? There are few common techniques to create sparse embeddings. So let's see. Number 1, regularization. Encourages more values to move towards zero. Number 2, gating mechanism. The model learns features to activate or ignore. Number 3, hashing techniques. Similar features are grouped together, reducing dimensionality. Number 4, attention-based methods. Used in modern architectures to dynamically focus on relevant dimension. So each method has its pros and cons, but the goal is the same: reduce complexity without sacrificing relevance. So yes, it works in the real world. Sparse embedding representation aren't just theory. Companies like Google, Meta, Amazon use them in large-scale recommendation engine, search ranking system, and personalized content delivery. They help speed things up, lower memory usage, and still deliver highly relevant results. Beyond tech giants, this concept is gaining traction in healthcare, finance, and even voice assistants. Anywhere smarter, fast, and focused models are needed. To wrap it up, sparse embedding representation help your model cut through the noise. They highlight what's important, reduce what's not, and make everything more efficient. If your model is bloated or you are dealing with massive input spaces, this is your sign to give sparse embedding a serious look. If you found this helpful, do like, comment and share it to your friends and loved ones. Thank you.